The problem says that the charge entering the positive terminal of an element is Q is equal to 5 sine 4 pi t millicoulomb, and the voltage across the element from positive to negative terminal is 5 is equal to 3 cos 4 pi t volts. So these two are given. We need to find the power delivered to the element at t is equal to 0.3 seconds, and also energy delivered from 0 to 0.6 seconds. So charge is given, and that is 5 sine 4 pi t millicoulomb, and voltage is 3 cos 4 pi t volts. So I is dq over dt. So we differentiate to find the current, because to find the power we need current. Voltage times current is power. So when we differentiate this one, it becomes 20, this one 20 pi sine cos, sine will become cos 4 pi t, and the unit will be milliamps. Since charge was millicoulombs, it will be milliamps. So our power will be VI. So voltage here is 3 cos 4 pi t, and current will be multiplied by current, which is 20 pi cos 4 pi t. And power we need to find at t is equal to 0.3 seconds, because power will be instantaneous, it will keep changing. So at 0.3 is equal to 0.3 seconds at time, basically at 0.3 second, what's the power? So once we plug in t is equal to 0.3 in this equation, we get voltage to be, that's what I have got, minus 2.427, and current is minus 50.83 milliamps. So the power is becoming milliwatt. So we can see that the power, once it's multiplied, it's becoming 123.36 milliwatt. So the power is positive, which is supposed to be, because this element essentially is absorbing power, because current is entering. In the question it says current is entering through the positive terminal, and voltage drop is from positive to negative terminal. That means this is a passive element, it will be absorbing power, and we are getting the power to be positive, so its power is being absorbed by the element. So that's there. Now we need to find what's the energy delivered to the element from 0 to 6 seconds. So we know energy is p dt, and from 0 to 0.6 seconds, 0.6 here. So this will become 0 to 6, and p will be 3 cos 4 pi t times 20 pi times 20 pi cos 4 pi t dt. So we can take the 60 pi outside the integration, and this is becoming cos square 4 pi t dt. Now this is square, so what we want to do, we want to write the double angle, use the double angle formula of trigonometry. So it will become half of 1 plus cos 8 pi t dt, and 0 to 0.6. So if we take the half outside the integration, it becomes like this. So 1 plus cos 8 pi t and dt, like that. So once we integrate it, it becomes t plus 1 over 8 pi sine 8 pi t, like that, and 0.6 here, and 0 here. So this one will become 30 pi here, and this is 0.6, plus this will be 1 over 8 pi, and then this is sine 8 pi t, so sine 8 pi, and then times 0.6. so times 0.6, and then minus 0, and sine 0 is also 0, so these the lower limits ones are becoming 0. So once we put this thing in calculator, we will get the result that I got is 58.75. again it will be joules but millijoules, because power was milliwatt. Now what I forgot to tell, when we plug in the angles in the calculator, we have to ensure that the calculator is in, the angle is in radian mode, because all these arguments, the cosine arguments or the sine arguments here, these are in radian. So that we have to check whether the calculator is in radian mode, because if it is in degree mode we will get wrong results. So this is the problem basically, this is the solution basically. Since I have rounded off at for the decimal at various stages, so I rounded off a bit, so just double check. The answer may differ a little bit from your result, but pretty much this is the procedure.